Mr. Paladin, this is Math 155. This is Chapter 3, Section 2. This is Part 3 of the video with logarithmic functions. The last part is graphing logs with transformations. The same transformation list here is stated as the previous section and previous chapters. The difference being is specifically ones and pretenses to the logs. Keep in mind that the order of transformation still applies here, so you know it's a log function. The order still applies, so the order of transformations is the order of operations. So the horizontal translations must happen first. The scaling must happen second, which would be shrink or stretch. The reflections over the x or y axis must happen third. And lastly, the vertical translations up or down must happen fourth. Okay? And clearly this has an inside and an outside. There's an inside for the x values inside a log for this one. Okay, I'm just going to change the scaling here a little bit. Okay, so if we go back and graph a standard log base 2 as we did before, you will get this graph. And we need to pick out a few points similar to what we did in the exponential section. So we'll take this point here, which is 1, 0. We'll take this point right here, which is 2, 1. And we'll take this point right here, which is 4, 2. And this point right here, which is 8, 3. Why did I pick those 4 points? Well, there are an infinite number of points to pick. You might as well pick the ones that are nice whole numbers, and those are the nice whole number ones, at least the first few of them anyways. You need 3 to 4 of the easy points to translate around. So if I look at this problem, I have several things. I have this right here, the -1, which is a horizontal translation. I have a scaling vertically. It's because it's on the outside. And I have a reflection. It's on the outside, so it affects y. Inside affects x, outside affects y. It's on the outside, it affects y. So if I change my y value, I went over the x axis. So based on the order of operations, log base 2 of x minus 1 must happen first, because it's a horizontal translation. Then the scaling must happen second, so the times 2 must happen second. And then lastly, the negative reflection must happen last. Okay? Alright, so if I do the -1, that's counterintuitive, which means I must go to the right. So if I go to the right, 1, 0 becomes 2, 0. 2, 1 becomes 3, 1. 4, 2 becomes 5, 2. And 8, 3 becomes 9, 3. Okay, so our original asymptote was x equals 0. Since I moved 1 to the right, this is also going to move to the right for the asymptote. So now it's x equals 1. So there is our new graph. And our new coordinates are 2, 0, 3, 1, 5, 2, and 9, 3, because only the x value changed because we translated to the right. So next one is a times 2, which is a vertical translation because it's on the outside. Outside's vertical, which is y. So we only change the y value. So 2, 0 stays 2, 0 because we're only changing y times 2. The next one, 3, 1, goes to 3, 2 because we multiply the y by 2. The next one, 5, 2, goes to 5, 4. And the last one, 9, 3, goes to 9, 6. And our asymptote stays the same of x equals 1. So we go up through those points. So our points, again, change to 2, 0, which is the same as before. 3, 2, 5, 4, and 9, 6. So again, we only change the y value because we vertically scaled by a multiple of 2. So lastly is a -2, which means we reflect over the x-axis because we changed our y value. So we went from positive y to negative y, so we went over the x-axis, which means our asymptote doesn't change. So our 2, 0 was on the axes. That doesn't change. It stays on the axes. Okay. However, the next point, 3, 2, goes to 3, negative 2. And our next one, 5, 4, goes to 5, negative 4. And 9, 6 goes to 9, negative 6. Because they reflected over the axes. So 2, 0 stayed the same because it's on the axes. 3, 2 went to 3, negative 2. 5, 4 went to 5, negative 4. And 9, 6 went to 9, negative 6. So what is our final domain and range? All right, let me move this out of the way here real quick. That's not x equals 0. That's x equals 1. That didn't change. Okay, so I'm starting at 1 and going to infinity, but I can't get to 1. My range up and down is negative infinity to infinity. Okay, pause the video and go to page 12 and try the student problem. Okay, so if you graph the basic log of base 3, you would get this graph here, which you did prior, which gives us the coordinates of 1, 0, gives us the coordinates of 3, 1, and 9, 2. Are there more than that? Sure. Why did we pick these ones? Because those are the nice whole number ones, and you can graph this for yourself by converting it to 3 to the y equals x, right? Into the exponential format. Those are nice easy ones, right? 3 to the 1, 3 to the 0, 3 to the 2, and those are the values they give. So we need to do the translations now and transformations. So of those, what happens? Well, the log base 3 of x plus 1 happens first, because that is a horizontal translation. And then the log x plus 1 of base 3. The reflection happens second. There is no scaling this time. And then the negative log base 3 of x plus 1. The plus 2, which is a vertical translation, happens last. Okay, so if we do the plus 1 on the first step, that's actually moving left 1, so it only affects x. So 1, 0 goes to 0, 0. 3, 1 goes to 2, 1. And 9, 2 goes to 8, 2. So we translated to the left 1. So our old asymptote was x equals 0. Since we went left 1, it's x equals negative 1. Okay. So now we have a reflection on the next one. That's our next step. So this doesn't change. That stays at x equals negative 1. So we reflect, which only, it's on the outside, so it affects y, so reflecting over the x-axis. It only changes the y value. So 0, 0 is on the axis. That doesn't change. 2, 1 ends up being 2, negative 1, and 8, 2 becomes 8, negative 2. So we get our graph like this. And our coordinates are 0, 0, 2, negative 1, and 8, negative 2. Because the negative on the outside affects y, so it only changed the y value, which puts us over the x-axis. So lastly is plus 2 on the outside as a vertical translation that only affects y. So 0, 0 goes to 0, 2. 2, 1 goes to 2, negative 1 goes to 2, 1. And 8, negative 2 goes to 8, 0. The asymptote stays the same of x equals negative 1. So I went forever down and forever up. but I can't go past -1 on the left side, but I am going for the right forever. So there's our final domain and range. And that is the end of part 3.